In this video, we are going to see about machine learning introduction as well as its applications. Definition. What is machine learning? Machine learning is nothing but where we are teaching the machine or machine is learning. If we want to get a definition of this, the famous one was made by Tom Mitchell. What he says is a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance a task in T as measured by P improves with experience. Here, the experience is nothing but whatever the data we provide. That is nothing but an experience. And task T refers to the output of the refers to the output whatever is required. And performance P it refers to the quality of the output. What general learning definition is? Learning is nothing but improving of one's behavior based upon the experience. So here based upon the experience, we are improving the performance of a task. That's what is nothing but about a definition which is said by Tom Misher. Now, the one more common dot whatever we will be getting is what is the difference between the traditional programming as well as machine learning? So, if you take it here, the traditional programming or in a conventional programming or till date whatever we are using in case of a normal programming language, what we will be giving? We will be giving an input data as well as we will be giving an algorithm. So this algorithm works for the whatever the input data we have given, and this machine utilizes this algorithm as well as input data and it produces an output. So for example, if I want what is in a 2 into 2. So if I give a input data as in a 2 into 2, or for example a into b, for a into b I will be writing in a program. If I feed to an a computer what's the value of an a, value of an a as a 2 and value of an b as a 2, then computer programming will be giving me as a 4. That is a conventional programming. But if I am coming to the machine learning, here what it is doing is nothing but here we will be giving an input data as well as output data as well as output data. What does this output data refers to? This is nothing but these are some of the instances or some of the data which previously we know the results of that. So based upon that data, here we have given an input and an output to a machine. Based upon that, the machine will be generating an algorithm for us, and here this algorithm will be working for an data where we don't know the output or which will be creating an output for our own requirement. That's what. So here in ways of a conventional, we are giving as an input data and we are giving an algorithm so that algorithm is working or it is giving an output. But in case of machine learning, we give a data where the data consists of input as well as an output. So based upon that, it will be generating an algorithm. With this algorithm, we will be getting the desired results. Now we have seen how the algorithm is getting generated in case of the machine learning. Now, what is the use of this algorithm? Now, this algorithm is developed with the help of the machine learning. So, where we are going to use this algorithm? Here, this algorithm can be used for the learning models or in a building of a model for data. So, this is can be used as a learner's model, or these models can be used for the making of any decisions, or it can be for any predictions. If you can take in case of any some applications like statistical data prediction, or in case of a healthcare sector for the prediction of a disease, or logical decision making, or many kind of things we can be used for help of these algorithms. And these algorithms are the one which are utilized to solve the tasks. Previously, we have said that what is the task? Task is nothing but a T or which is a required output to to get the required output, here we will be using this algorithm. This is nothing but a learning box representation or a black box representation in case of machine learning. Why we are calling this? Because here we will be having a box kind of representation. In this box, we are having two items. One is nothing but called as a learner, and second one is nothing but called as a reasoner. So, what is the role of this learner and what is the role of this reasoner? Now we'll be going to see in detail. Here, for the machine learning, what are the inputs we are giving? We are giving an experiences data, or this is an data which we are providing. Along with that, we will be giving an some sort of a background information or a background knowledge which the system is going to gain, and then we are giving an a problem and or in a task. So what is this? Here, whatever you are giving a experiences data or in a background knowledge, here you are having an inputs plus an outputs. So with this input and output, it is going to make in some learning. So after this learning, what it is doing? It is getting preparing in some algorithm or in some model or in some logical solution. That solution is shared with a reasoner. So now the task of reasoner is nothing but here we are having an input data, but we don't know the output. So to get that output, we are using this reasoner, and with the help of this reasoner, we will be getting an output for this task or a problem. So based upon this, what is the performance we are going to get? That is nothing but a quality. Whatever the output we are getting, it is nothing but that is a result of it, or the performance is nothing but this is a quality or an answer of a task. Applications of machine learning. Here we have many applications almost in each and every area we can be able to use a machine learning. So some of the applications which include medical diagnosis, computer vision, robot control, and natural language processing. So, for example, in medicine, you can use machine learning to diagnose a disease where the input at the symptoms or in the lab measurements or test results or DNA tests or etc. And based upon these results, what could be the output? The output could be one of the possibility that whether there is a disease or there is a no disease. For example, if you are giving a set of patient's history, so it will be giving an output for this particular patient. This is scope that the diagnosis of this may occur this kind of a disease. For others, there will be a nothing. And how it is going to do? For this, one can determine the historical medical records and learn with future patients. So what it is doing? It is learning the previous history of an data of various patients, and then it is predicting for the future patients. That's how it is going to be taking care. The another domain where we can see it is in a computer vision, where you are giving an image, and once you give an image, it will be finding out the output, what it is, whether it's in a object or it is in a person or it's in a thing or in a anything. So based upon that, it can be seeing. So it's nothing but called as in a computer vision. And one more interesting application is nothing but in a robot control. Robot control. One can use machine learning to design in a autonomous mobile robots and then to learn them for the navigation system or for their own experience, or it can be used for an industrial application or in a multiple ways we can use in a robotic control. And one of the interesting application is nothing but in a natural language processing. So here, what it can detect is it can detect what are the reviews of in a movie, or like whether it's in a positive or it's a negative or it's in a neutral, and it can recognize the speeches, or it can be done for many other ways. So here it is nothing but a natural language processing. This is one of the application where you are most commonly using for your movie reviews or for your kind of in a speech reductions or in a multiple things. Okay, the some more applications which include the fraud detection. If there is a suspicious transaction happened in case of a credit card or in a debit card transactions, we could be able to find it out with the help of a machine learning, as well as we can be able to make a prediction that, or based upon the statistics we can be able to predict that, or we can able to forecast which stock is going to be rise or fall in the next day or in a next week. And also we can be able to say that, identify the price sensitivity. For example, which item is getting a hiking of a price, or which one is getting a price decrease, or which one is available in a which location. So if I go to what's the nearest location to me, what's the optimal price. So if I go from this place to I want to purchase, for example, a mobile phone. So now in the which locality or in a which place with which cost it is going to be available. So which is an optimal solution for me. So if I want to travel for 50 kilometers and it want to be reduction of the price is 10 rupees. Or if I go in a 2 kilometers and the price is in a 50 rupees more. So which one I want to select. So those kind of options also it will be predicting in a forecast with the help of this machine learning. So till now we have seen in a various applications. So now if we want to see how it is going to work, or how machine learning is going to work with respect to various applications. So these are the some of the major steps which it has to pass through, or which it has to follow. So the first and foremost step is training data. This is nothing but this is an experience, or whatever the data set which we are feeding to a computer. That is nothing but called as with the help of this training data, it is going to get a required amount of analysis, or it is going to perform on this training data, and it is getting observations. So what kind of observations it is doing? So now next, once we are having training data, what is the next step? We have to know the target function. What is this target function? The target function is nothing but, for example, what is the output which we are aiming for? What's the output which we are aiming for? That is nothing but called as target function is nothing but what is the output which we are aiming for. For example, if I take a checkers game. In the checkers game, what's the next move I want to do? That is the target. So how I am going to get that move, or how I am going to achieve that move? That is nothing but we will be getting in the next step. That is how to represent the target function. So here now we have any training data. Now we know what we want the output. Now the next step is how to represent that, or how to represent the target function, or how to achieve the target function. So we may be having a possibility. So here we are getting in what way I can able to get that function, or achieve that function. That is nothing but how to represent the target function. And the last step is nothing but learning algorithm. So based upon this requirement, we are developing an algorithm. How it should be the algorithm? If algorithm is it should be more common in way, such that it can be used for further applications also. And in the same way, it should not be very much complicated, so that it may be taking in a lot of efforts or energy. So it should be in a best possible ways. So here now, if we come back to summarize these steps from the training data, what we are getting what are the features we are going to get, or what is the requirement we are going to get, that we are going to get it from the training features, and how to represent the target function. Third step. Here it is nothing but, here it is the main or in a core logic, or here this one we will be calling as in a class of functions also. And this is nothing but called as a hypothesis. About this class of functions or in a hypothesis, we will be discussing it more in the next. Thank you, guys.